Hello, this is Mrs. Huntley. This is Module 3, Lesson 9, Basic Properties of Similarity. You should be on page 71 of your module, and your essential question for this lesson are what are the basic properties of similarity? So we have an exploratory challenge, and the goal is to show that if triangle ABC is similar to triangle A prime, B prime, C prime, then triangle A prime, B prime, C prime is also similar to triangle ABC, meaning it goes back and forth. Symbolically, if we write that, we would have a little triangle, ABC, and then this squiggle line means similar to triangle A prime, B prime, C prime. Then it's true in reverse as well. So we're going to spend a few minutes talking about how do we prove similarity between two triangles. Okay, we've got two triangles that are different sizes. They look like they're similar. And perhaps I could figure out a scale factor and see if I can translate one on top of the other one or do rotations or whatever it might take for me to get one to map on top of the other. But there's also some other ways that I can prove the similarity. And we talked a little bit about how the angle measures, if something is similar, your angle measures are going to be the same between angles that match up. So we have angle A here, and we have angle A prime. So those would be our corresponding angles for A. And then of course we have B and B prime, C and C prime. So those are our angles that we're going to check and see if they have the same angle measure. And I have a little protractor here. I've been practicing with it, so I'm getting better at it. But I am still struggling a little bit, so please don't make fun of me. Um, I purposely made our triangles darker behind so that you can see them when the protractor is on top of them. And as you can see, here's one of our legs. Here's our AB leg. And the other leg is coming through, and that's at the 0. Right here it says 0 on the protractor. And then this one's coming through right at 50. So the angle of measure, or excuse me, the measure of angle A is 50 degrees. Now I'm going to scoot my protractor down, and I'm going to measure angle B really quick so that I don't have to move my protractor to the other triangle and then come back again, because for some reason the protractor is fighting me, and in fact it's fighting me a little bit right now. There we go. Okay, so I've got that lined up. Oh, come on. At 0, and if I come over here, this line is coming across the protractor at 95 degrees. So the measure of angle B is 95 degrees. So the measure of angle A, we said, was 50. Measure of angle B is 95 degrees. Now I could measure angle C, but what I'm going to do is mathematically figure out what angle C is. Remember that the interior angles of a triangle sum to 180. So if I take 95 plus 50 plus the measure of angle C, I'm going to get 180 degrees. So when I add together 95 and 50, I get 145, plus the measure of angle C is going to be 180. I want to get the measure of angle C all by itself, so I'm going to subtract 145 from both sides. And the measure of angle C is 180 minus 45, which is 35 degrees. So this one should be 35 degrees. So let me check my other triangle to see if these are similar triangles, because all triangles have 180 degrees in them. So let's start with the measure of angle A. I'm going to try to get that right on the vertex there and then spin it around if I can get the little spinny thing to show up. Come on now. There we go. All right. Oh, it went a little farther than I wanted it to. Ah! Oh my goodness. Okay, so we're lined up on 0 there. Let's follow this out, and that line would go up, and we are right on 50. Now don't get confused where it says 130. The protractor goes in both directions. The 0 over here is the inside rung. The 0 on the outside is the outside rung, and that's the one that I'm looking at. You can see that this line matches up, and if I follow it all the way out, it's at 50. I know this is an acute angle, so it wouldn't make sense that it's 130 degrees. If this was continuing, you know, if I had this line continuing here, this outside angle would be the 130 degrees. So okay, good. Angle A is congruent to angle A prime. Let's check angle B and see if I can get this on there and then spin it around. and it didn't stay where it was supposed to. Let's scooch it over. There we go. And here's our 0 and following it up. And it looks like it's between the 90 and the 100. I'd have to extend this out to be more exact, but it looks like it's right at 95. So angle A prime is 50, angle B prime is 95, and of course that's going to make C prime 35. Because again, the interior angles of your triangle are always going to sum to 180. So our angles are congruent between these two triangles. So right there, by angle-angle similarity, or by the angle-angle criterion, I know that these two triangles are similar triangles. The other way I can prove it is by checking the proportionality of the sides. Now, it doesn't really matter which triangle you start with, whether you start with the big one or the small one. What matters is that you're using corresponding sides and that you're consistent. So if I'm starting with my AB side, I've got to stick with my AB side. And if I'm dividing if I'm starting with my prime and dividing by the one that's not prime, I've got to stick with that pattern. Okay, so I'm going to start with AB prime, and I'm going to divide by AB. So AB prime is 2, and AB is 4. So I can reduce that fraction to 1/2. Now I'm going to check with B prime C prime. And I'm going to divide that by BC. And I'm just checking the ratios of the two sides. So BC is 3, or I'm sorry, B prime C prime is 3, and BC is 6. And that again will reduce to 1/2. And let's do the final side. So CA prime is 4, and CA is 8. And again, 4/8 is the same as 1/2. So the proportion is 1/2 on all three sides of my triangle, so I know my triangle is similar. So to prove the similarity, first check corresponding angle measures or check the proportions of the corresponding sides. If all of the sides are in proportion, or if 2 out of 3 angle measures are the same, you know that third one is going to be the same as well without even checking it. Okay, so that's how we can prove similarity. So if I wanted to go ahead and describe the sequence of a dilation followed by a congruence that proves triangle ABC is similar to triangle A prime, B prime, C prime, what would I do? Okay, that's proving the big one is similar to the little one. Okay, so I would have to shrink my big one by a scale factor of 1/2. So first I'm going to dilate by 1/2. Then I would need to get them close together. Maybe I could draw a vector from A to A prime, and then I'd have to rotate around A until C mapped to C prime. So if I was describing that, this is how I would describe it. I'd say dilate triangle ABC by a scale factor of 1/2, translate along vector A prime, and rotate, I said, until B maps to B prime or until C maps to C prime, either way. Now, if I wanted to go the other direction, if say I wanted to get my little triangle to map on top of my big triangle, I'd have to grow this one by a scale factor of 2 and then do the same thing. I'm going to be translating along the vector and rotating around A prime until B prime maps to B, or until C prime maps to C. Either way, I'm just going in that direction to go back. I hope that makes sense to you. I hope this is becoming, pretty simple to see that if how to do the rigid motions without actually getting a transparency and doing them, because we should be at the point where we don't have to. So it says, is it true that triangle ABC is similar to triangle A prime, B prime, C prime, and that A prime, B prime, C prime is similar to ABC? Why do you think this is so? So just like rigid motions prove congruence, and congruence is symmetrical, which means it works in both directions, so does similarity. So if I usually use like a math example here where we're talking like about the properties of addition or the properties of multiplication. It works in both directions. So 3 plus 2 is 5, just like 2 plus 3 is 5. So it works either way. I hope that makes sense. I don't even, let's just say if one thing is similar to the other, the thing that it's similar to is similar to the first thing. Okay, second exploratory challenge. Here's where having some colors might come in handy. And let me take a look here. This is one that actually might be a little bit tricky to do with the program, but I'm going to try. The goal is to show that triangle ABC, ABC, this little one down here, is similar to triangle A prime, B prime, C prime, this one up here, and that A prime, C, B prime, C prime is similar to ABC, so this one is similar to this one. Then ABC is similar, then okay, let me back up and start talking again because I just really made a mess out of those directions. I'm going to read the directions and then I'll start pointing at things. So the goal is to show that if triangle ABC is similar to triangle A prime, B prime, C prime, and that A prime, B prime, C prime is similar to A double prime, B double prime, C double prime, then triangle ABC is similar to A double prime, B double prime, C double prime. Symbolically, if ABC is similar to the one with 1 prime and the one with 1 prime is similar to the one with 2 primes, then the one with no primes, the original, is similar to the one with 2 primes. So what we have to do, we're trying to prove that this little one is congruent to this one, and that not congruent, similar. This one is similar to this one is similar to this one, therefore this one will be similar to this one. Kind of transitive. Okay, how are we going to do that? First, we could check angle measures. I'm going to save us some time because working with a protractor here is really tough. The angle measures are congruent. So we're going to check and see if we can figure out some scale factors. So if I want to get from this guy to this guy, what scale factor would I use? Now, the easiest way for me to do this is to say AB prime is equivalent to the scale factor times the original length of AB. Plug in what I know and solve for what I don't know. You know what? Actually, I'm going to use BC instead of AB because they're whole numbers. Easier. So BC prime is equal to the scale factor times BC. And this is BC prime, so that's 3 is equal to the scale factor times 1. So to get the scale factor by itself, I'm going to divide by 1, and so my scale factor is 3. So I'm going to dilate triangle ABC by a scale factor of 3. So where is A right now? A is at -1, 2. B is at -3, 1. And C is at -3, 0. So if I dilate by a scale factor of 3, I'm not going to call it A prime because we already have a prime up here. So I'm just going to call it A sub 1. -1 times 3 is -3. -2 times 3 is 6. B sub 1. -3 times 3 is -9. -1 times 3, I'm sorry, +1 times 3 is 3. And then for my C, -3 times 3 is -9. 0 times 3 is going to be 0. So I'm going to dilate this shape. So -9. Okay, I shouldn't have written things there. And I would totally start recording over because I've made such a mess of this. However, we're already 15 minutes in and I don't really want to. So I'm just going to move this up here. That actually worked pretty well. Okay, so I'm going to dilate my guy. So -9 is right there. -9, 0, so that's my C prime. Or C sub 1, sorry. C sub 1. -3, 6, 1, 2, 3. 1, 2, 3, 4, 5, 6. And then that's A sub 1. And then -9, 3. And that's B sub 1. So I'm going to connect these all with a straight line, and I'm going to make mine green. And then I'm going to group this drawing together so that I can move it all. That's so not what I wanted to do. Let's lock that in place so it doesn't wiggle on me again. And then I'm going to group this guy. I'm going to try that again. All right, we're just going to group it all. Okay, then I need to translate it. So I'm going to draw in a vector. So that's why I wanted to group it, because if I move this now according to that vector, oh, why didn't you group with the rest of it? Darn it. Let me see if I can regroup. Okay, that's not what I wanted to do. It's not working. It worked when I was practicing. Let's group. Try again. Group it. Okay. Now if I translate this along that vector, it should map perfectly. Except it's not going to. Oh, it started moving, didn't it? No, that line started moving. All right, well, we'll move it one line at a time then. And hopefully you can see I've moved everything along that vector and it does map. So I know that if I dilate triangle ABC by r equals 3 and then translate up along vector A sub 1A, it's going to prove that similarity. So I'm going to just go ahead and type that out. Okay, so if I dilate triangle ABC by r equals 3 and then translate up vector A sub 1A, which I drew in here, and then I just typed it out here, I described the similarity that proves triangle ABC is congruent to triangle A prime, B prime, C prime. Now I need to describe the similarity that proves that this one is congruent to this one. Okay, so I again need to figure out my scale factor. I'm going to again use BC and B prime, or B double prime, C double prime. So I'm going to go from B double prime, C double prime equals the scale factor times the length of BC. So plug in what I know. B double prime, C double prime is 2. I don't know the scale factor. BC is 3. I'm going to divide by 3, divide by 3. So my scale factor to go from this triangle to this triangle is 2/3. So again, I need to figure out where my current locations of A, B, and C are. And A prime is at -3, 11. When I multiply that by 2/3, my A, I'm going to get A sub 2, and that's going to be at 1, 7 1/3. B prime is currently at -9, 8. And when I multiply that by 2/3, that should be a B sub 2, is going to be at -6, 3 1/3. And finally C is going to be at negative 9, 8. And that's going to be, when I multiply that, C sub 2 is going to be at negative 6, 5 1/3. So I'm going to go ahead and draw that one in. I'm going to change colors to red. And let's see. Okay, I drew the triangle in, and I paused the video for me to go ahead and draw that triangle in because I was struggling with the program, and I didn't want that to take up all of the time, and I realized that I'm already over time, and I've probably confused some people, and I didn't mean to do that. So now you can see that my two triangles are the same shape. I'm not going to attempt to move them because, again, that was just kind of disastrous, although it did work for me when I was practicing. But apparently it's not going to work when I'm live. Anyway, I drew in a vector from A sub 2 to A. And so if I translate this triangle along that vector and then I rotate around until B sub 2 maps to B double prime, I will prove that they are congruent. So describing the similarity, I would dilate triangle ABC. I'm sorry, that was A prime, B prime, C prime, wasn't it? So I need to add those primes in by 2/3 and then translate along vector A sub 2, A double prime, and rotate around A double prime until B sub 2 maps to B double prime. Now this is just, I'm growing this, or I shrunk this shape so that it would be the same size as this shape, and then I can map one on top of the other to prove the congruence. That's what I'm doing. Now the final step that I have to take is to verify that the original triangle is similar to triangle A double prime, B double prime, first by checking corresponding angles and corresponding side lengths, and then describing the sequence that would map the similarity. I'm going to go ahead and skip that step. I would have to grow this triangle by a scale factor of 2 and then translate along vector. I draw in another vector between A and B and then rotate, and again until B maps to B double prime. The whole thing that I'm trying to prove to you is that similarity is transitive. So let me go ahead and give you the last note on this. I don't know what's happening. It's not letting me type. I'm struggling. I'm on the struggle bus here. Okay. Similarity. Okay. Is transitive. What that means is if, and I'm going to just use the pen because I'm struggling. If triangle ABC is similar to triangle A prime, B prime, C prime, and triangle A prime, B prime, C prime is similar to triangle, oops, that should be a triangle, A double prime, B double prime, C double prime, then triangle ABC is also similar to triangle A double prime, B double prime, C double prime. I struggled a lot with this lesson because of the technology. If I've confused you, I apologize. It was not my intent, and I know I went over again. I will make it up to you, I promise. Thanks. Bye.